You ever really think about the screen you're looking at right now? I mean, we spend so much of our lives staring at these things, but the story of how they went from just being screens to becoming these hyper-realistic windows, well, it's one of the coolest stories in modern science. Today, we're diving into the quantum dot revolution.
We all want the same thing, right? A screen so perfect that you forget you're even looking at a screen. You just feel like you're looking through a window. And it turns out the key to that grand vision wasn't some huge, complicated machine. Nope, it was a crystal. A tiny semiconductor so small it plays by the weird, wonderful rules of quantum mechanics.
Yeah, it's all about this quest to, as Samsung puts it, see the greatness, to capture the world with all the color, all the depth, all the detail that just takes your breath away. And that whole journey starts by understanding the tiny little hero of our story.
All right, so what is this thing, this quantum dot that's completely changing our screens? To really get why it's such a big deal, we've got to get into the science just a little bit. Okay, so a quantum dot is basically a man-made nanocrystal, and it has this one truly magical property. When light hits it, it glows. But here's the amazing part. The color it glows is determined with insane precision just by its size. It's all because of something called quantum confinement. Think with it like a guitar string, right? A shorter, tighter string gives you a higher note. Quantum dots do the same thing, but with light. Let's break this down. It's actually super simple. If you make a quantum dot a bit bigger, we're talking like 5 nanometers, which is crazy small. The electrons inside have more room to move. They're less confined. This makes them give off lower energy light, which our eyes see as a perfect, pure red. And if you shrink that same dot way down to about 1.5 nanometers, well, now those electrons are really squeezed in there. They have more energy, and they release that energy as higher energy light. The result? A perfect pure blue. So by just tuning the size, bigger for red, smaller for blue, and somewhere in between for green, you can create any pure color you want. This incredible level of control, that's the whole ballgame. So you have this incredible new tool. What's the first problem you try and solve? Well, instead of starting from scratch, the engineers did something really smart. They took the most common screen technology on the planet, the LCD, and decided to make it way, way better. This was the first big evolution, the birth of the QLED TV. See, your standard LCD TV has this one big fundamental flaw. It needs a light behind it to make a picture, but pure white light is actually really hard to make. So for years, most TVs they've cheated. And that little cheat is why older screens can look kind of washed out and muddy. So here's the cheat. A TV takes a cheap blue LED and just slaps a layer of yellow phosphor over it. Now your brain gets tricked into seeing this messy mix of blue and yellow as white, but it's not. It's a really broad, imprecise spectrum of light. So when that messy light tries to pass through the tiny red, green, and blue filters that make up your pixels, a ton of light gets blocked, and the colors kind of bleed into each other. You end up with a dimmer, less vibrant picture. But then came the quantum dot solution, and it was just brilliant. They got rid of that sloppy yellow phosphor. Instead, they put in a film packed with quantum dots. So now, the pure blue LED light hits this film. Some of that blue light just passes right through. But the rest hits these perfectly sized red and green quantum dots, and they convert the blue light into perfectly pure red and perfectly pure green. Suddenly, instead of one messy light source, you have 3 perfect ones. The result? Brighter, more efficient, and unbelievably more accurate colors. But even with this huge upgrade, QLEDs still had a backlight, and because of that, they could never create a truly perfect black. That was the one thing its biggest rival, OLED, did perfectly. See, with an OLED screen, every single pixel is its own light. To make black, a pixel just turns off. Simple as that. The downside? OLEDs use organic materials that can wear out over time, which leads to that dreaded burn-in. So for a while, you had to choose. Do you want the incredible brightness and pure color of QLED, or the perfect infinite contrast of OLED? But, engineers, they asked a much better question. Why do we have to choose? What if you could just take the best of both? And that question, why not both? Well, that's what kicked off the second major evolution in our story. This was the moment technology took its next great leap, aiming to fuse these two rivals into one super display, the QD OLED. The idea they came up with was just
Genius. Instead of a big backlight, Samsung created a panel made entirely of blue OLED pixels. This gives you the light source, and, this is crucial, it gives you that ability to turn pixels completely off for those perfect inky blacks. Then, they just laid a sheet of red and green quantum dots right on top. So the blue OLEDs make the dots glow pure red and pure green, while the blue in the picture is just the light from the OLED itself. It's the perfect marriage of the two techs. And once they had the idea, the industry moved at light speed. In 2019, Samsung drops a massive, nearly $11 billion investment. Just 2 years later, they're in mass production. And by 2022, you or I could walk into a store and buy a QD OLED TV. That's an incredible pace. And the results? They were stunning. QID OLEDs could show 90% of this super demanding color range called Rec 2020. Now that's a lot of jargon, but what it means for you and me is that these TVs can create colors that were literally impossible to display on a screen before. Deeper, richer reds, and more electric greens. It just set a completely new bar for what a great picture looks like. But you know how technology is, right? It never stops. Even this amazing hybrid tech isn't the final destination. The journey now is pushing towards what many consider the true holy grail of display technology. A future where the quantum dots stop being just a filter for light and become the light itself. This is a tech called QDL, that's for quantum dot electroluminescence. The idea here is, instead of using light to make the dots glow, you use electricity to do it directly. Each individual quantum dot becomes its own tiny microscopic LED. Think about that. No backlight, no OLED layer, no color filters, nothing. Just pure, direct light from the dots themselves. The potential here is just staggering. We're talking about displays that are way more power efficient, that last longer than OLEDs, and because you can literally print this stuff, you could have incredible, flexible, even rollable screens. Now, it's still in the lab for now, but some people think we could see the first products hitting the market around 2026.
So QDEL sounds a little like science fiction, doesn't it? Well, guess what? While we're waiting for it, you don't actually have to imagine a self-emissive future. A very similar technology, called micro-LED, is already out of the lab and in the real world. Just look at this. This is Samsung's The Wall. It's made of millions of microscopic, inorganic LEDs, a tiny red one, a green one, and a blue one for every single pixel. Just like the QODL concept, there is no backlit, there are no filters, it's just direct, brilliant light. And the results are, well, they're just breathtaking. And the benefits are everything we've been chasing this whole time. The absolute purest blacks, because the pixels just turn off. Unbelievably true-to-life color. And because it's built out of these modular tiles, you can build a screen in pretty much any size or shape you can dream up. This is that greatness we talked about at the beginning, but made real. So you start with a crystal smaller than a virus. And through this relentless wave of innovation, you end up on the verge of completely erasing the line between a screen and reality. It's an incredible journey, and it leaves us with one last, really exciting question. As these windows on our walls become absolutely perfect, what new worlds, what new art, what amazing stories are we going to be inspired to create and show through them?